afternoon everybody. I'm Andrew. I'm going to do the tour for you today. We have a Lancaster NX611 and welcome to East Kirkby. How many of you have been on a restoration tour this year so far? A few of you. Yeah. You'll have seen that we did a complete survey of the aircraft, a paint strip, looked at the condition of the outer skins, looked into various areas on the aircraft to then produce the work packs required to make the aircraft airworthy. The plan is, so this is year one, so what we're doing with the project is breaking it down into winter seasons. So this being year one, the main work for this season, this winter restoration, is the complete bust down and rebuild of the starboard tail fin and rudder systems. This is obviously the port, so the vertical fin and rudder. So they've been completely bust down, surveyed, repaired and rebuilt, and starboard side again, so right hand side, the trailing edge has been taken off for survey and some repair work, and the starboard inner engine, so number 3 engine, has been removed to allow some parts to be NDT'd and tested behind them. So obviously first thing, everything was taken off that was required to be off. We had some jigs made for the fin and rudder for the starboard side. They came off the aircraft onto the jigs and again were drilled and bust down from that point. So a little bit later on I'll take you around to show you the progress with the fin and rudder. Starboard side, we're taking off the starboard inner engine, which is the number 3 engine, which is on the power plant stand directly behind us, which you can look at after the tour. So that engine comes off as its power plant, so that's engine bearers, radiator, basically bulkhead forward comes off in one section and sits on the power plant stand. Then that leaves the bulkhead and the subframe, which come off in one section, and then after that we had the undercarriage support beams to take off as well. So the main aim for taking all that off this season was to test the undercarriage support beams. The undercarriage support beams are a large cast or forged aluminium section, and if I have one strong person, so this is an undercarriage support beam. So it's an aluminium cast item or forged item, which is then machined and weighted away in certain areas and holes drilled. The top here, so the face where my right hand is sits on the main spar of the aircraft. So that's the forward face of the main spar, and then this protrudes forwards. On the bottom end there is where the undercarriage is bolted to it. The top end here, there's a big bolt that runs through here through the top spar, and a big bolt that runs through to the bottom spar with more bolts through the web of the spar. The top one here, these lugs, is where the subframe bolts on, and at the very bottom you should have the bottom of the subframe and the undercarriage. So there's 2 of these on each side. Both of them have been NDT'd, so all the holes have been eddy current tested to make sure there's no cracking around the holes, and it's passed as perfectly serviceable as it came out of the factory effectively. Okay, put them back now. It is quite heavy, so we will put it down. So those have come back from NDT, all serviceable, have been painted up and they're ready to go back on the aircraft. So the first stage of rebuild of that project is to paint the front face of the front spar. So for that we need a little bit of heat in the hangar. As you can tell, the heating is not working right now. So hopefully today or Monday the engineer's coming out to fix that, which will mean that we can then paint the front face of the front spar and bolt these items back on. When they're back on, hopefully the subframe will have returned to us from being painted. So that'll be next week. And then we can start to build everything back up again and put the engine back on. Onto that, the subframe is basically a tubular structure. I don't have a photo of it, but it sits between the undercarriage support beams and the bulkhead, and it transfers any stresses and any weight in a particular way across the aircraft to make everything safe. That subframe being a tubular structure, it can suffer corrosion on the insides of the tubes. So that tubular structure subframe has been away for NDT, it's been x-rayed, and we found the internals of the tubes to be very good. But there are just some tubes that have got some chafing on them where various panels fit and various parts fit onto them. So it's come back to us, it's perfectly safe for taxiing, but there are a couple of tubes that need replacing for airworthy. So that's going to be cleaned again, it'll go through paint, come back, have this built up, engine back on and go back on the aircraft, and then within that work pack it'll have just a small section that says next time it comes off, those tubes to be replaced and can be classed as airworthy. So that work will be done when the centre section is worked on, because it's all got to come back off again anyway. So once the bulkhead and the subframe go back on, we can then just bolt the power plant straight back on, prop on, cowlings on, dome on, and then that's all finished, ready for the finish of this winter work. Okay, so if we go around the back of the aircraft, I'll talk you through. Look at the aircraft on the starboard side, you'll see the fin and rudder's been removed. So that's the outer extremity of the tailplane. So they came off, taken off the aircraft, they only unbolt, the fin comes off with 4 bolts at the back and 4 at the front, so only 8 bolts hold the fin on, and then the rudder's only held on by the hinge to the fin. So rudder was removed and put onto the jig you see just here, and then the fin was removed and put on this jig here. What we do is put them on the jig to make sure all the hinge points and everything line up with the jig. We then put the top of the jig on, as is on the rudder here, and that then shows us where the fin should line up on the bottom and the fin should line up on the top, so that when it's taken apart, put back together again, everything lines up as it did before it came apart. So this is the fin jig, and you see the main post from the fin has been riveted together and has just been troll fitted back onto the original jig. This will come off again, be cleaned down with Scotch-Brite and repainted, and then from that point be put back on the jig and everything will be built back up from it. What we'll do first is everything will be dry fitted, so it will be fitted using skin pin Clico clips. So the fin post as is here will be bolted down, and then all the ribs will come in. The ribs are here. So ribs such as these will all be fitted back on. Majority of these are actually original, but we have had to replace quite a few of these ribs because of corrosion or oversized holes. So these will come back on, Clico pin down to the structure, and it'll all be built up from the bottom upwards. The way the fin's built is it's got several posts that run through it. So there's the main post at the bottom here, then I have an intermediary post which is laid on the desk here. It's at the longest post, and that runs from the tip here all the way through and sits on top of here. Then there's one more post, and then there's the leading edge, and that's all held together with small sections like this which fit between the posts all the way up to the leading edge. The leading edge of the fin is actually made of wood. Originally it was mahogany, and it curves from the top here in a large curve all the way back down to the very bottom of the fin. So how it originally looked when we'd taken the skin off is like this. I don't know how well you can see that, but you see the jig down here. On here is the original fin post as this, and then the leading edge curves all the way around the top and all the way down to the bottom, which is just there. And it's laminated wood, so it's strips of thin wood which is then glued together and shaped to fit the actual shape. So before that leading edge was taken off, we had the woodworkman come in and take a shape of the fin itself. Then we took it off the fin, cut it in half and sent it away to him with all the like a jig to hold it back as it came off the aircraft. He's obviously had that back in his workshop, and he's produced the leading edge, the new one, to fit this one. Originally, I'd say it was mahogany. Because mahogany is a controlled substance now, the replacement is going to be ash. So it's another hardwood, and it's a super modification to be made because of the mahogany being a controlled substance. So that will come back to us. It'll be dry fitted, and it'll have its final shaping done while it's here. When we're happy with that and we've got the shaping looks to be okay, we'll also fit one side skin on it of the original skin to make sure that everything lines up with the original skins, make sure it all fits the shape as it came off. When we're happy with that, the skin will come off, the whole structure will come back apart, all the Clico pins removed, and then we'll start to rivet it together from the bottom up again. So in effect, you're probably putting it together 2 or 3 times before you actually finally put it together. When we've got the structure together, we'll also fit a skin make sure everything lines up. We've got a few new skins to go on this because of corrosion on old skins. So we'll also be producing some new skins, making sure everything lines up before the skins and everything's finally riveted together. The wood is screwed to the fin itself, and then the skins are in turn screwed to the wood. And there's 800 screws in each fin to hold the skins to the wood. Those screws you have to pilot drill the wood first. You then have to secondary drill it. You have to dimple the skin and dimple the wood and then screw it in. So there's, I think, about 3 or 4 different things you have to do before you can finally fix the skin to the wood. So just putting the skins onto the wood is going to be quite a period of time, making sure everything's right. Because once you've drilled wood, you've drilled it, and that's it. When you build them back up, you build them into their smaller assemblies. So this item here is made up of probably about 10 different parts, which are then riveted together to make this small assembly, which then contributes to the whole fin. So in the workshop, they've been taking the individual parts and making them into their assemblies, shall we call them, like this one. So this is a couple of different pieces which are riveted together, which is then brought to the fin to then be riveted to the fin. So the little assemblies have been made up already, and a couple of them are on the bench there as well, so that the guys on the shop floor, all they have to do is take the item out of the box and assemble it to the jig. There's no extra assembly required as an intermediary stage, because that's all been done back at the workshop, the on-site workshop here. So the fin's pretty much there to be going back together again. The rudder, we're just waiting on a couple of extra parts that have been refabricated. That has to go to be painted, then the rudder can be built up separately as well. On the bench here, each stage that we do, everything that we do to the aircraft has to have a work pack produced for it. So that work pack basically says, take it off the aircraft, take it apart, remedy anything, what have you remedied, note it, put it back together again and sign it off. But you'll see in the work pack that each engineer has a stamp, approval stamp. So each engineer on the books has a number from 1 to 30, and they stamp for each piece of work that they've done. So the person that took it off will have stamped to agree that they've taken it off, the person who took it apart, and so on and so forth. Because we've had several bits reproduced, this is an original and the new one. So the original suffered from corrosion and oversized holes, so a new one has been produced. So that will go through the work pack to say that this part number, which is 15/758, has been reproduced. It's used this material by this person, and the accepting engineer has stamped to say he's happy with it, he's happy with the production and the material that was used, and that will all be noted into the work pack, so that if the CAA come round in 20 years' time and say, I see that you replaced rib number 7 of the starboard fin, show me all the paperwork, our engineers can give them a book and says, this is the work pack of the work that we did, this is where the material came from, this is the certificate of conformity to say the material is sufficient for the job, and if you want to track back, you can go all the way back to the factory where the original material was rolled before it even came to us here. That's the same with every rivet that's used, every screw and bolt and nut that's used. You've got to have traceability all the way back from us here to where it was originally produced and the metal that was used when it was originally produced. There's an awful lot of that positioned within the trailing edges and the panels within the wings. So the starboard trailing edge has been taken off and is situated on the trestles just beside the aircraft there. Those have been taken off to inspect the rear face of the rear spar, and they've been taken off to replace the anchor nut strip within the access panels. On the trailing edges down there, you'll see there's brand new panels have been put in place on the bottom of the trailing edges, and that's where the anchor nut strip has been replaced or been put in. So the anchor nut strip has been put in as opposed to having to drill out and replace pop rivets all the time. When you want to take off the trailing edges, you have to drill out pop rivets to remove those panels to then undo the bolts that attach the trailing edge to the rear spar. In the new way that Lancasters are operated, as set out by British Aerospace and DBMF, that trailing edge has to come off every 8 years for inspection. So if we didn't do a modification to use anchor nut strip, every 8 years we'd be drilling out pop rivets, possibly having to oversize them, damaging structure, having to drill them out. So the new way of doing things is to use anchor nut strip and screws So you just undo the screws, drop a panel, and you can inspect inside and remove it. So there's been an awful lot of work gone into that. Last year we spent, I think, about 12,500 on an anchor nut strip. This year we spent 7,500 on an anchor nut strip, and that's all we need. So just shy of 20,000, and we managed to replace the anchor nut strip on the aircraft. So as I said, this year is going to be replicated next year on the port side. So next year the port fin and rudder will be off using these jigs. They'll be reproduced. Not reproduced, but surveyed and replaced where required, and they'll go back on the aircraft as airworthy. And the same with the port trailing edge, the port inner engine, and also the port outer engine will be coming off next year as well, to do the same with the subframes on that. So each winter, piece by piece, we're working through the aircraft and eventually have a completely airworthy aircraft. They say, how do you eat an elephant? And the answer is a bite at a time, and that's the way really we're working through this elephant. Okay, so you're more than welcome to have a good look around the aircraft, a look around at all the pieces that we're doing, have a look at the parts of the fin and rudder on the bench here. You'll also see some Cleco pins in one of the holders there, so you can see how the skins are held together before the rivets go in. There's an aluminium piece here which is still bare aluminium, which is a newly fabricated rudder post. So that's the main structure for the rudder. That's been reproduced for us. Just to tell you how these are made. These are basically made using wooden formers. So a hard wood is cut to form the shape of the item, so this kind of triangular shape. A hard wood former will be produced for that, and then the aluminium skin is cut to fit, and then it's just basically beaten around the former. So the skin is beaten around to form the shape. Then it's taken off the former, the lightning holes are put in, and it comes to us. We have them not with any holes in it, because the original skin had lots of holes where the skins are attached to the aircraft and where it's attached to the actual rudder or fin. But we drill those in situ so that we haven't got copy drilling and things to do, we can drill new holes. Just as an indication, this skin here, the new item here, will have cost about £400 to reproduce. And there's a couple of boxes full. The rudder fin post there, so the new aluminium looking item, that was about £1,400 because of the shape of it. So costs begin to mount up if you have to reproduce items. We're hoping that we would take the skins off and find that actually everything was fairly good and there weren't going to be ribs to replace, but the aircraft's 70 years old. We took the skins off, there was very little paint in there, so there's very little barrier to corrosion. So we did find several items that have just got corrosion too deep to be airworthy. They might have been okay to continue taxiing, but they weren't classifiable as airworthy. So do have a good look around. With this item, pre-planning. With the wooden leading edge we're having 3 of those made. So one for this side, obviously one for the other side, and one for a mistake. Those leading edges are costing us £5,500 for the wooden leading edges, and we've spent probably about, just shy of £5,000 on new ribs and new parts for the fins and rudders. So at the end of it, I'll be able to tell you what the winter's cost us, so we know what it's going to cost us for the opposite side. The whole project's looking about £4 million as a total. And again, obviously this is broken down into winter periods so that the cost is spread over for us to make it slightly more palatable. So next winter is the opposite to this winter. The winter after that will be the rear fuselage section. So after the D, you'll see there's a transportation point within the fuselage. That's where it will be split. The tailplane will come out from the fuselage. So that's just bolted in the centre. The tailplane will be removed and jigged on the sides, and then the rear fuselage section itself will come down, be lowered down to the floor. It will be gutted inside, everything looked at, checked, paint stripped, put back in. The outer skins will be, I imagine, will be repaint stripped, re-riveted where the rivets need replacing. So it'll all come apart, go back together again, and then be bolted back onto the aircraft. And then we'll work through the fuselage and wings during that process. So probably the year after that will be the mid-section, which is basically the section that holds the aircraft codes, so the DXF. That section will come off, same will be done, go back on, then the bomb aiming position, then the nose, the cockpit section, and then we get to the hard bit, which is the wings. The wing tips themselves come off, They again have a wooden leading edge, and then all the structure inside, it'll be de-skinned and all the structure will be done inside those. Then we have the outer wings, which sit between kind of where the inner trailing edge hits the rear spar there to the wingtip. That main wing section there, one side will be done, then the opposite side, and then the centre section will be done. So eventually we'll end up with a completely airworthy aircraft. Yes, thank you very much for listening to me.